In this sample calculation, we're going to find the work done by a
This is the
spring
office hours
or a
video
spring force,
for
is a better way of
section
putting it,
4,
as we move a package
geometry.
attached to the free end of the spring from x equals 0 to x
Now,
equals
one thing that
17
some people get
millimeters
confused about is the
along
difference
floor.
between
Now, the x equals
surface
0
area and
is said to be
cross-sectional
the
area.
position of the
So,
rest
as an
length
example of
the
that, I
spring,
thought I would
or the
look
relaxed
at a
length of the
cylinder.
spring. No compression,
So here's
no
a
extension.
cylinder. You might think of it as a
Well, we're
can,
given some information about
surface
the
of a
spring.
can.
We're told
And
that if we move
let's
the
compare
package to this
the
point, x equals 12
surface area
millimeters,
with
then
the
it
cross-sectional
takes
area.
4.9
So first of all,
newtons
if I look
from
at the
us
surface area of
as
this
the R
object,
force to hold the package there.
it
at
actually
12
has
millimeters.
3 surfaces.
Well, let's
So
do
what I'm
the
going to do is
calculation for the work. We want
add
the
the
work
areas
done and moving
of all
the
3
package.
surfaces
I'm not
together.
quite sure how to use this other information just yet.
There are
Let's
2
go get
ends,
a key idea here.
and then there's the curved part.
The work done by a spring
So
force
the area of each
the
end is going to be
spring
pi r squared,
given
which is
by
the area of a circle.
this formula from the
And then I need to add to that the area of the curved part. Now, the way you can think of that is to think of
the
circumference of a circle,
squared,
and then
minus
stretching that
K
circumference of a
final
circle down the
position
length
squared.
of the
Usually
cylinder.
when we have a subtraction
So
or
the circumference
change
of a circle is 2 pi
it's
r,
final minus initial, but
and then
because of
you'd
funny
multiply
minus
that
signs
by the
going
length
on
of
in
the
the
cylinder.
calculation here, we've got just the reverse.
Now what I want to do is
We're going to
simplify
use
this as much as
to
possible.
calculate the work
I'll give the
done.
surface area
The
the
initial
symbol A.
position is going to be x equals 0, and
So
the
if I add
final
the
position is going to be
2
17
areas of the
millimeters,
ends together, that's
expressed
2
properly
pi
in
r
terms of
squared.
meters. But there's a little hitch. Can you see the
And
hitch?
then, to make this easiest
K.
to use, I'm going to
It's
factor
not
all the
given
common
over here
terms
at all.
out.
How are we going to
So
find K?
here's the final expression.
And that's where this other
2 times
information
pi
comes
times
into
the
play.
radius,
We need to
and then
apply
what's left is
on
the radius
packages
plus the
here,
length.
a force to the right.
So that would be the
4.9
area
newtons.
of the surface of
In
the
order
cylinder,
to
and
offset
that area
the
is
force from the
boundary
spring, which
between
must
the
be in
object,
the opposite
the cylinder,
direction,
and its
hence
environment.
negative 4.9.
Now if I take that cylinder and
we can
slice
find
through
the
it,
spring
then
constant from that information.
I would be measuring the
Because we can write
cross-sectional area.
down F equals
So imagine that this
minus
is,
K times
I don't know,
the position, and it's going to be 12 millimeters.
a loaf of bologna.
10 to the
And I
minus
take a
3
knife
meters,
and I cut through it.
and
So let's say I cut
apparently
through it
the
this way.
spring force
I chop
the
right down
package
through the
is
middle.
at that position.
And when I
the
do that,
spring is
what I
elongated
get
by that
are
much. The spring
2
provides
smaller
a force
cylinders.
of 4.9 newtons. We can solve for K. In fact,
And so the
here is
cross-sectional
the
area would be
calculation.
the new areas that's
We find that
exposed.
the K is
Now really, in this case, there are 2 of those. I'm not going to double count
now
them. I'm just
we'll
going
go
to
after
count
the
them
work
once.
done and moving
So
the package
the cross-sectional
from 0
area in this
to
case,
17
if
millimeters.
I slice it
We're going to be plugging into that formula.
perpendicular to the
It's
length,
going to be, I'll write it down again,
then that cross-sectional area
initial
you can see
position
is just the area of a circle.
and
And again, I'm
final
not going to double
position,
count.
and
I'm not going to
0
count
for
both
the
of those
initial
circles, just
position.
one of them.
Final position
So the
is just
cross-sectional
going to
area
be
would be
17
pi r squared.
times 10
And you
to
can
the
see that's
minus
different
3
than the surface
meters.
area.
The K we
Let me
just
use the symbol
discovered
for
is
that.
408.
Unfortunately, a lot of times we use the
Here's
same
the
symbol,
numbers
A,
expressed
for area.
typed
So you have to know
out
from the
in orderly
context
fashion instead of my
what the symbol is
scribbles.
standing for,
We
surface
find
area
that
or a
for
cross-sectional
that
area.
displacement, the spring does
Now what would
this
happen if
much
we took
work,
the same
negative
slab
0.059
of
joules.
bologna, and instead
Next.
of
we got the package
cutting
all
it
the way over there
perpendicular
at
to its
17
length,
millimeters, and now we're going to move
we cut it across the middle
to
like
the
this.
other side of the 0 mark to x equal
And so
negative
if you
12
cut through it like that, let's say
millimeters.
it's exactly through the
And
middle,
again, we want to know how much work
what you would get, the
does
surface
spring
that would be
force do on the
exposed,
package during
if I look at it
this
from the top,
displacement?
would be a rectangle like this.
Well, we're going to use the same formula.
Oops.
It's
Try
going to
that
be
again.
the work is equal to, the work done by the spring is going to be equal to
So
1/2
the cross-sectional
K
area depends
x
on how you
sub
slice
I
it,
squared
which way
minus
you
1/2 K
cut the object.
x sub F
So
squared.
in this case,
We're going to
we
put
get
the
a
numbers
rectangle,
in. The initial
and
position this time is 17
two sides of this rectangle are
millimeters,
the length
or
of
more
the
properly,
cylinder,
17
and
times
then
10 to the
on the
minus 3
sides,
meters.
that's the diameter of the
The
circle,
final
which
position
is
is
the
going to
same
be
as
negative
twice the
12
radius. I'll
millimeters,
just write D for
re-expressed
diameter.
as meters.
So in
The
this
minus
case,
sign will of
if I
course
cut it
disappear because we're
in a different
squaring that
direction,
coordinate.
the
What we get
cross-sectional
out is
area
positive
comes out to be
0.030
D
joules,
multiplied by
or if you
L.
like, 30 millijoules.
And if I wanted to express that in terms of the radius,
this is how much work
the
the spring
diameter
has done, and this time
twice
that
the
work
radius.
is positive. And the
So the
question here
cross-sectional
is,
area would be
why is it
2 times the
positive?
radius
When
times the
we
length.
pulled the package out,
So it's important to
elongating
recognize the difference
spring,
between
the spring did
surface
negative
area and
work.
cross-sectional
We
area.
did
This will become
positive
very
work,
important
the
later
spring
on
did
when we
negative work.
start talking about
How come the spring is doing
how
positive
energy
work?
moves from one place
Well,
to
it's
another because of
when
the
the
temperature
spring
difference.
brought the package in
That
from
kind of
17
energy is
millimeters
called
to
heat.
0. It
And the
did
amount
a
of heat that
fairly
flows
large amount of
in various
positive work.
cases will depend on
It will do
one of
a
these kinds
small
of area
amount of negative
areas.
work
So it's a good idea
during
to
the
distinguish
compression from x equals 0
them
to
as soon as possible.
negative 12
And I recommend that you go through
millimeters.
the same procedure for other
Large
shapes,
amount of positive
for
work,
example,
bit
spheres
of negative work,
and cubes,
overall a positive
simple shapes
amount
like that,
of work.
because
And
that'll
that's
be
it
useful later on.
for this video.
So go ahead and try that out, and we'll see you later on.